So we'll start this up. All right. Oh, a preview, let's call it. All right, so last day, right, we started and we talked about simple interest. Right? We talked about the amount of interest that we can calculate. So for a quick review, because it was just on Tuesday and we've got a lot to get through today. So for review, we started simple interest. We talked about calculating I, which is PRT, and then solving for P and solving for R and solving for T in this equation. Because they're all being multiplied, it's not that hard, right? But where I is the amount of interest, usually, let's say earned, right, or owed. P is the principal, investment, or loan, right? And so investments and loans behave the same way. It's just an investment, you invest money and then it makes interest, so you earn interest, right? Or a loan, you borrow money and then you have to pay it back with interest at a later date, right? And so principal, investment, or loan. It's extra slow today, I'm noticing. I don't know why though. Yeah, because usually by the time I look up there, it's done, but now it's all slow. Anyways. R is the interest rate. It has to be per year, right? And so we looked at some examples where, you know, it was 2% per month. Then we had to multiply it by 12 to get it per year, right? 24% per year. And then T is time in years. We talked about the days between dates function on your calculator. All right, so our calculator, we can calculate the number of days between two dates, and we're going to use that in examples later, so I'm not going to review it right now, right? But we will go through it and cover it once more. Well, probably more than once, but right, so we can use our calculator to find days between dates, or the number of days between dates. And then we talked about the future value. Future value of an investment or loan. The future value is the principal amount plus the amount of interest. But that's not what's on your formula, right? But that's still true. But what's on your formula sheet is a little bit tidier, because we can replace I with PRT, right? I equals PRT, and so we can plug that in for I. So we get plus PRT. So the future value. We can pull out, we can factor out a common P, and so we get P times 1 plus RT. And that's the formula on your formula sheet. We looked at problems where we had to solve for the future value, and I think we did one maybe, I can't quite remember off the top of my head if we solved for one with a present value, but I've got another example up my sleeve. So we looked at examples solving for the future value and P. What we're going to do, as soon as we introduce a new formula, we're going to work through it and solve for every individual thing, right? So we're going to start, how do we solve for the future value? Great. How do we solve for a present value? Today, we're going to keep going. How do we solve for the rate? How do we solve for time, right? And so each little bitty thing that we could solve for in one of these problems, we're going to work through kind of methodically, okay? And so today, we're just going to keep going and solve for R and solve for T and look at how those behave. So that's kind of the end of the review. Any questions so far? No? Okay. All right. Before we get any deeper, I want to talk about timelines. And so timelines we use to kind of organize our thoughts and organize the information from a problem. And so it lets us visualize the problem. In the beginning, they're going to seem kind of pointless and quite frankly, a little bit hard to do. But we start now, right? We start early because what we'll see is these questions quickly get kind of out of hand. And so we need to have these timelines kind of locked in, and so that we are really comfortable making timelines, because what I find when I'm marking test 2, test 3, and even the final exam is I can look at your timeline and I'll know how many marks you should get, right? So a lot of it hinges on your timeline because it's just about organizing the information, and it's very rare that someone gets the question right with a wrong, like without a timeline. And so you kind of have to have a timeline to get to the answer. Okay? And even showing your timeline is a way for you to show me how you interpret the information, right? And so even if your timeline is wrong, then what I can do is I say, okay, well, you actually thought that this was happening, and if that was true, then yes, this would be true, right? And so it's a way for you to keep a lot of marks, right? It's just having a really thorough timeline. So what is a timeline, you ask? Timelines. We use timelines to organize the information. The information we have been given. And to plan our calculations. As we get deeper, it's going to get to the point where we have to solve for one thing before we can solve for another thing. And it's not until we've mapped it out that we'll be able to see it clearly. Okay. So I want to talk about kind of the general anatomy of a timeline. So what does a general timeline look like? Okay. So the general anatomy of a timeline looks like this. All right, how do I wanna? Problem is I added a little thing at the bottom of my notes, but I really wanna have it at the top, but I don't know how to do that. So anyways, it's gonna look like this. So far, it looks like a timeline, right? Kind of from one point to another point in the future, right? You go to the bank, you deposit some money, pull it out in the future, what's it worth? Right? So what we do is, what I'm gonna say is, all the things that you have to enter I'll put in pink. Okay, so here you've got date 1. And over top here, you've got date 2. So the dates go on top of the ticks. Okay. Then we have below it, we put the amounts, the dollar amounts, right? Because we're talking money, right? And so we go in on date 1 and I deposit some money. That's my P, right? So that's my principal amount. And so this is my P amount. And then it sits there earning interest until I take it out on date 2, whatever the date that is. And that's my future value amount. So we put dollar amounts underneath each date. Even if we're trying to solve for the future value, we just say, here goes a future value that I'm going to be solving for. So even if it's a blank, you just fill it in and say future value, and you'll see what I mean in an example, but then you can just leave it as future value. But you have to have all these pink components. Okay? Well, and the blue ones too, but the pink ones are the ones that change depending on the question. So then what we do is we draw an arrow from the principal amount to the future value. Okay. This arrow represents time. So whatever the time is, and for simple interest, we're going to be talking about time in years, right? And so you want to have the time in years. It might be days divided by 365, right? Or months divided by 12. But you're going to put that there. Or if you're solving for t, you can just say t equals question mark, but all the other pieces have to be filled in, right? Except for date 1 and date 2, you might not know those, right? If you're solving for time. And then the only real other thing that we need, if we're looking at this future value, is the principal times 1 plus RT, right? We've put our future value on there. We've got our present or our principal on there. We've got T on there. The only one that's missing is R. There's no real spot to put it, but just to have everything nice and neat in one package, I just kind of put it down here to the side. R equals. So it doesn't really belong anywhere on the timeline, but I like to have it there so I can remind myself, oh, the rate is this. We could also have the arrow going this way from the future value to the principal amount, right? And so those questions would be if we were solving for the principal amount, right? So we're usually given one and we have to find the other, or we know both and then we're solving for T or R, right? So same as the formula, it's just a kind of a summary of whatever's in the question, and then it shows you what you have to solve for. Okay. So what I'm going to say is that the arrow represents time. The arrow represents time. And it points in the direction we are, and then I'll put in quotes, moving the money, right? We're not moving it, but it's just sitting there. So whether we're taking the future value and we want to know what it's worth today, or if we've got some deposit and we want to know what it's going to be worth in the future, we're moving the money. in terms of time, right, the present value is always going to be on the left, and the future value is always going to be on the right, right? And so we can move from the present value to the future value, or from the future value back to the present. Oh, sorry, I used PV, I shouldn't have. It's weird because we use PV, the present value, as soon as we get into compound interest, and they'll be the same, right? But we'll use P for now. But just a heads up that they'll be the same. Okay. And so,
does that make those terms interchangeable for the test?
yes, yeah. So principal is the same as the present value, right? So principal can also be called the present value, right? So P equals PV, in case I slip up again. I think the idea on the formula sheet, because I didn't make this, it's just kind of pre-made. I think the idea is to keep it nice and simple for simple interest, and then we build into, but I do find it confusing with the different notation, but as long as you've got a handle on the P and the PV, they're the same, right? So this idea that P, the present value or the principal, is always on the left, and if you're moving, if you find yourself drawing an arrow towards the right, you're going to be solving for the future value, or whatever's on this side is the future value, right? And so that presents a lot of trouble for a lot of people, right, in this course, is they end up putting a future value over here and solving for future values, but it doesn't really make sense because then you've earned interest when really you should be solving for a present value. But this is always the case. P goes on this left-hand side, future value goes on the right-hand side, and then the arrow just denotes which way we're moving. Okay. So what I'll do is I'll put a little note here. Always on the left, and the future value is always on the right. And either way, the arrow represents time. So just a note, right? If we're looking at our timeline, all the components of the formula have to be accounted for in our timeline, right? All the things that we might need in our formula has to be on our timeline for it to be complete. Okay. So all the components of future values P times 1 plus R times T must be accounted for on the timeline for it to be complete. The only one that we're going to leave as unknown, right, is the one that we're solving for. The value we are solving for can be left as a variable. Where's this remote? Oh. Let's see if I can get rid of this buzzing. The last thing I want to mention about timelines in general is when you're reading the problem, you're going to want to count out all the dates that are mentioned, because each date that's being mentioned has to get a tick up here. So here we only had date 1 and date 2, but it's very possible to have 5 dates, right? So we make a deposit, we make a withdrawal, we make a deposit. How much do we have on this 5th date, right? And so we need to know, well, how much do we have left here? So then we're talking about 5 dates. So then it gets very kind of out of hand, right? And so you want to make a tick for each date that's mentioned in the problem. So each date mentioned in the problem gets I don't know what else to call a tick on the timeline. And then each tick is going to have an arrow either coming to it or going from it, depending on which way the money's moving. Right. So each tick will typically, there are rare cases where the money doesn't move, will typically, have an arrow going from / to it, depending on the scenario. Any questions about that? Then I think we should do an example. So just a little itty bitty, mostly for the timeline, but also to solve for the present value. We're going to do example 145. Oops. Judith. I suspect it was supposed to be Judith, but I guess it works. Judith received the proceeds from an inheritance on March 25th. Nice. She wants to set aside enough on March 26th, right? So she got it, and then she's going to the bank the next day so that she will have $20,000 available on October 1st to purchase a car when the new models are introduced. Nice. If the current interest rate on 180 to 270 day term deposits, that's just a decoy, right? The 180 to 270 days, it's really just there to check that you get your days between dates right? It should be in that range. Term deposits is 3.75%. What amount should she place in the term deposit? Okay. So we need it to have grown to 20,000, right? So that's going to be the future value. And then what amount do we need to deposit initially? That's our principal, right? Or our present value. And so to map this out, we've got 2 dates. It mentions 3, but one is kind of, she got this money, doesn't have anything to do with us, right? And so in terms of the problem, we've got 2 dates, March 26th and October 1st, right? And so I'll start by making our timeline here with 2 dates. On top, I put date 1, right? March 26th. And on top of the next one, I put October 1st. Because it's a timeline, right? So they have to be increasing. It doesn't mention a year, so we're just going to pick a year later on because we know that for our days between dates function, we have to have a year. But we can just pick any year as long as it's the same year. Right? All right. So, okay, we've got our dates. We've got the beginnings of our timeline. Underneath our dates, we put our amounts, right? And so what we know is that we have to have $20,000 on October 1st. So what we have to do is we have to pull this backwards to find P. Because if we're pulling it backwards, right, P is always on the left, future values on the right, right? And so just as a little note, because this is our first timeline, probably, unless you do them in other courses, I don't know. I don't think so. No, who needs them? This is our future value, right? On the arrow, we're going to put our T. We don't know what it is, but we can solve for it, right? Because we have the days between dates function, so we kind of know it. But for now, let's just put the rate down somewhere, anywhere. So the rate is 0.0375. I always just go straight to the decimal version. Well, sometimes I remember and I do the 3.75% or 0.0375, but because we use the decimal in our calculations, that's the one that I write down, but it doesn't matter. As long as you change it before your calculations, you're safe. So we need to find T, right, using dates between, or DBD, days between dates. Remember how to show your work for when you're using your calculator. You're going to list all the inputs. So it takes date 1, it takes date 2, and it takes DBD. To indicate that we're solving for the days between dates, we're going to put a star here. Right. Just so I know that that's the one that you solved for, the other ones you punched in. And as a little reminder, remember, it needs it in the format month, month, dot, day, day, year, year. Okay. And I'll do because it was last day, I'll set up my little, you guys will have the answer by then. But still, nice to show it. Okay. So, okay. Oh, I guess I forgot to write out, hang on, what my month, dot, day, day, year, year should be. The first date is, the month is 03, 03.26, and then I'll pick this year. Pick any year. And then October 1st is 10.0119. And I'll just make a note that it has to be the same year, right? Because it didn't say October 1st a year later or 2 years later, right? But we could handle something like that, but we don't have to. So now I can go into my calculator here. There. Some glare. What would we do without any glare? That's pretty good. All right, so to access the days between dates function, it's over the number 1 button, date. So we go second, date, and then to enter our first date, cute, 03.2619. That's not saved yet, right? You want to make sure that you hit enter, right? Enter. And it should be looking like this, right? Then you know it's saved. So it's not saved until it says date 1 equals whatever. Now remember, we scroll down to date 2, and we enter date 2 the same way. So we had 10.0119. Again, it's not saved until it says date 2 equals whatever. So we hit enter. Nice. Now we go to days between dates. We scroll down one more. Days between dates, it'll just have the most recent value that it calculated until you get it to compute. So then you hit CPT, compute. So there's 189 days between those 2 dates. So that's what we can use for T. So 189. I'm actually gonna put this back down. Oh, I'll keep this handy. It's really hard on my wrist to write when it's up top. Yeah. 30, huh? Let's see. So close. All right. Phew, nothing major. All right, so now we know that the time is 189 days, but time, remember, has to be in years. And so time is going to be 189 divided by 365. Remember from last day we said we assume that every year has 365 days. Right? 12 months, 52 weeks, all that fun stuff. Okay? So, all right. So we've got T, we've got R, we've got the future value. The only thing that we don't know is P, right? And so now we've mapped out this problem and we can see that what I need to solve for is P. Right? So now we can solve for P. But this is what I would consider a complete timeline, right? It's an itty-bitty problem, but it's good to get started with these little guys because then we'll kind of get the hang of it and then the bigger ones won't be a problem. So P, we've got the future value is P times 1 plus R times T. The future value is that 20,000. P, we don't know, we're solving for it. Times 1 plus R, which was 0.0375, sorry. Times T, which we said was 189 over 365. So now we can simplify inside our brackets and then move it over to solve for P. You could move it over first if you'd like, but I always like to simplify before I move it over, but it's just up to you, personal preference. 20,000 is P times 1 plus, and then I'll solve 189 over 365. And then times 0.0375. Remember, you have to deal with that multiplying and dividing cluster first, right? Bed mass, multiplication, division, that's dealt with first, and then we can add the 1, right? That's going to be really important. So we get plus 0.019417808. So showing an extra step, you don't actually need to show that 1 plus 0.019 is 1.09 or 019. Can't say it. 1.019417808. I'm just showing all the steps, but you could probably skip that one if you wanted to. Now to solve for P, I like to have P on the left-hand side, or whatever I'm solving for on the left. And so now I can say, okay, well, to get P on its own, I would have to divide both sides by 1.019. And so I get 20,000 divided by 1.019417808. So plus 1. And what I'm going to do is I'm going to make a little note that I've stored this in 1. Right, I've stored that value in 1. That's more of a note to myself where I stored things, right? So remember, you can store values. I guess here we go again. Martha Stewart, but not so prepared, I guess. Well, as prepared as I can be when you're going off the cuff here. All right. I think I've shown you guys before how to store values, but it's really valuable, pun intended. So here we go. So if I want to have this big value stored in my calculator, I'm going to hit the store button, STO, and then I have to tell it where I want to store it. And so you can think of all these 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as storage spaces. Right, so you can put it in a slot and forget about it. So I'm going to hit store, and then I'm going to put it in 1. It doesn't do anything. That's a flaw of the calculator. It kind of says, yeah, sure thing, but it doesn't tell you about it. But then now if we clear, what I can do is I can hit recall 1, and it just pulls up that number. Right. So now what I can do is I can do 20,000 divided by recall 1 equals, and then I get my answer 19,619. Right. And so we're going to get really good at kind of using the store and the recall functions. So it's worth reviewing here. Right. So we got P is 19,619 point, and I'll show all my decimal places more so that you can check that you check to make sure that you get the same values. 04122, but P is in money, and so 19,619 and 4 pennies. So she would need to invest $19,619.04 on March 26th in order for it to grow to $20,000 on October 1st. So that's the answer. Any questions about that one? No. Nope. Moving on. All right. So, section 4.5, as promised, we're just going to keep going. So we've looked at examples solving for the future value, solving for the present value. Now we just keep going and solve for the rate of interest and the time or the term of the investment. So section 4.5 is the rate of interest and term of investments. Oops. Which is T, right? And the rate of interest is R. Okay. So if we start with R, right, we can show that we can manipulate the general equation to solve for R. But remember, usually I like to start with the default equation, future value is P times 1 plus RT, and then I plug in my values and then I solve, right? But you could just do this in the beginning and then plug them in, that's totally fine. But it's more so that we know how to manipulate it in general. So solving for R, and just to highlight it a bit so that you can go back to it. Remember, the future value is P times 1 plus R times T. So if we're solving for R now, we kind of hold R steady and everything else moves around it. And so we get the future value over P is 1 plus RT. The brackets dissolve because they're not multiplied by anything anymore. We have to move the 1 over before we can divide by T. And so we get the future value over P minus 1 is R times T. And then we're going to divide both sides by T. So we get, and I like to have R on the left, so we get R is the future value over P minus 1 over T, just kind of tidying it up a bit so we don't have these huge nasty fractions. I've got another derivation, but I don't really think we need to look at it. I think we're better off just doing an example. Okay. Or do you guys want to see me manipulate it back to I equals PRT? Can leave it to the reader, as lazy authors say. We leave it to the reader to do this. Oh, thanks. Let's do example 151 then. I'll be a lazy author today. Oops. Eek. Nope. I had to throw this in last minute because I changed my example that I wanted. Oops. But here we go. Mostly because it sounds really fun and really expensive. I'm not sure that they should go at all. But anyways, Andre and Shane can book their Vegas holiday package at the early booking price of $3,900 or wait 4 months and pay full price of $3,995. And so the question is, oh, I guess I cut out the question. Oopsies. Wish me luck. Copy. There we go. Of course, we're comparing the two, so here we go. Which option should they select if money can earn 5.25% rate of return? Right, so if R is 5.25%, then which is the better option? right? So the idea with these problems is Andre and Shane could take $3,900 to the bank and let it sit and earn interest, and then take it out when they need it 4 months later, right? Or if just paying the $3,900 now, right, is cheaper, then they're going to do that instead of paying the $39.95 4 months from now. Right? And so we've got two options. They can pay $3,900 now, or $3,995 in 4 months. So I don't know about you guys, but for me, it makes more sense to look at, okay, well, 3,900, what's that worth 4 months from now, right? We could have just as well said, well, what's 3,995 worth 4 months ago, right? Pulling it back. So you can see how, depending on which way we're moving the money, right? If it's from 4 months from now back to today, we're calculating a principal amount, right? So for me, it makes more sense to pull the 3,900 into the future, also because I like calculating future values more than present values. That's just me, right? And so if we map this out on a timeline, it's going to look something like this. We're still only dealing with 2 dates. They're less specific this time, right? But we can just say, okay, well, here we are today, because I think it's just kind of vaguely assumed that it's today, right? But it's today. And then here's 4 months from now. So a lot of the time, we're not going to have these specific dates. It's just going to be, he makes a deposit today, and then a year and a half from now, what's it worth, right? So we still put the dates on top, but they can be a little bit vague like this. And so what we want is we want to look at, okay, well, if I deposit, or if I pay $3,900 now, right, and let it sit there for t equals 4 out of 12, right? 4 months in years is 4 over 12. Then what is my future value? Right, so I just say future value there. That's a placeholder for what I'm trying to solve for. And then I just jot down what the rate is. The rate is 0.0525. That's the complete timeline, right? Because we have all the components. And just being able to make that complete timeline, that's going to take some work, right? That's going to take some practice. And so now we can calculate the future value is P times 1 plus R times T. P is the value on the left-hand side, so 3,900. Oops. Times 1 plus R, which is 0.0525, times T, which is 4 over 12. So again, we have to deal with the multiplication, the 0.0525 times 4 over 12, before we can add it to 1. Right? Otherwise, we'll get way wrong answers. So 0.0525 times 4 divided by 12. I get 3,900 times 1 plus 0.0175. $3,900 times 1.0175 times 3,900, I get 3,968.25. So the future value, and you don't have to because it didn't change. So then what we're saying here is, I'll just jot it down as a little side note, is that 3968.25. Okay, so 4 months from now, would you rather pay 3968.25 or 39.95? Right, I'd rather pay this, right? But in order to do that, you have to pay, that's this guy here, right? This guy, 3,900, had to pay in advance 4 months, right? But really what you're paying 4 months from then is actually only 3,968.25, right? And so that's how you're going to be able to compare values at the same date, right? You're going to pull values to the same date and compare them. I would rather pay 3,968.25 instead of $3,995. So they should select the early booking option, right? Because that's what the 3968 is. They should select the early booking option. Because it's cheaper. Okay. So, part 2, at what simple interest rate would they be indifferent between the two? So this one's a little bit different, right? Because now what we're asking is, okay, well, at what rate? So now we're changing the rate, so we don't know it. Time stays the same. The 3,900 stays the same. But now, essentially, we're trying to find what rate makes 3,900 equal to 3,995 4 months from that point. Okay? And so that makes a new timeline. So at what, just to summarize what we're answering here, at what rate would they be equivalent in value? Would they be equivalent in value? And this idea of equivalent payments is going to be huge in this whole course. Right? So now we've got the same timeline. We've got today, and we've got 4 months from today. Now we're saying, okay, I start with 3,900 and I'm going to force it to be 3,995 because then they're equivalent 4 months from today. The time is still 4/12, and I'm trying to solve for the rate. All right. So I know my future value, I know my present value or my principal, I know time, so now I can go through and I can solve for R. So I know that future value is P times 1 plus R times T. And just to emphasize it, because it is, we're just starting with this stuff. So this is P and this is the future value.
I thought the 39.95 was the current value because they want it cheaper in the future.
You could go that way. But because we didn't go that way earlier, I'm just going to stick to the same. But you should arrive at the same answer if you did it that way. Right? So what we're saying is you could have taken 39.95 and forced it to be 3,900. Right? Still find the rate. But like I said, I like finding future values because the P, if we're finding the principal amount, I have to do future value divided by 1 plus RT. It's just not as fun. So I like finding future values. In this case, we have the future value and the principal. So we get 30, oops, wrong color, gasp. 39.95 is 3,900 times 1 plus R, which we're solving for, times T, which is 4 over 12. So we can plug away here. 39.95 divided by 3,900 is 1 plus R times 4 over 12. So I get 39.95 divided by 3,900, 1.024358974 is 1 plus R times 4 over 12. To get R on its own, I have to subtract 1 first from both sides. And so I get 1.024358974 minus 1 is R times 4 over 12. So minus 1. And then R, to get R on its own, even though we've got 4 over 12, I can still divide it over because it's still just a number, right? And so I can divide both sides by 4 over 12. And I get 0.024358974 divided by 4 over 12. And you can actually use the brackets on your calculator, right? There's brackets here. So once you have 0.024 blah, 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 blah on your calculator, you can say divided by, and then bracket 4 divided by 12, and then close the bracket. And then that'll just make sure that you're really safe. And then hit equals, because otherwise it won't do it. So we find that R is 0.073076923. Right. So R is 7.31%-ish. I'm gonna just move this all down 1 because there's a page break. Oh. Any questions about that one? Is it giving you grief? Is that a problem? No? Good? Okay. So, no questions? Just keep going. Got it. Solving for time. Same idea as solving for R, right? We'll go through and look at the general form, and then we'll have a look at an example. So solving for time, we have the future value is P times 1 plus R times T. future value over P is 1 plus R times T. That's the same setup as before. Even now, when we have to subtract 1 from both sides, we get the future value over P minus 1 is R times T. Solving for T, we divide both sides by R. So we get T is the future value over P minus 1 over R. Okay. All right. Yeah, yeah. Because we do the same manipulations until we get the R and T multiplied, and so they'll behave the same way. Yeah. All right. Let's do example 155, which I think is a really funny example, and you'll see why in a little bit. Janet borrowed $15,000 from the Bank of Wayne, presumably her husband, on November 5th, 2001, for a new necklace. She's got to have it. The Bank of Wayne charges 7.45% simple interest. Interest accumulated amounted to $1,534.67. One thing to note, though, that's the amount of interest that she had to pay. On what date was the loan repaid? Okay. So this one is kind of an involved question because we've got things like the amount of interest that there's not really room for in our formulas, right? But we can remember that the future value is P plus I, right? And so what we'll do is we'll map this out, and then we'll kind of backtrack from our timeline, figure out what we need to solve for and what we kind of need to put together. It's also really funny because my parents have neighbors and their names are Wayne and Janice, and they call each other Wayne and Janie, so it's really a funny question to me, I guess. Maybe not to you, but I think it's really funny. Wayne and Janie. All right, so we've got a timeline. She borrowed some money, $15,000, and then she repaid it later at some unknown date, right? Because that's what we're trying to figure out. So, but she borrowed it November 5th, 2001. So we can jot that down. And the amount was $15,000 on that date. Here, I'm just going to put a question mark here because that's what we're ultimately trying to find, because the question says, on what date was the loan repaid? Right, so we're going to try to find this date here. That was a really ugly question mark, but we know the amount that she had to pay, right? We do have to do a little bit of work because she would have to pay back $15,000 plus 1,000. Oops, keeps rejigging here. 1,534.67. So that's 15,000 plus 1,534 67. 16,534.67. Right. So what that's saying is that 15,000 had to grow to 16,534.67. We still don't know the time it took because that's going to be a gateway to finding that date, right? So first we're going to solve for time, and then we can use the days between dates function to figure out the actual date. Right? So we're kind of working backwards, I guess. And then I'm going to jot down the rate somewhere around here. The rate is 0.0745. Okay, so that's what's going on. Right? We first have to find t, and then we're going to find the actual date. So we first find t, then we can find the date. So if we're jotting things down and making notes to ourselves, right, then the 15,000 is the P, right, and the 16,000 whatever is the future value. So if I've got the future value is P times 1 plus R times T, the future value is 16,534.67. P was 15,000 times 1 plus R, which is 0.0745 times T, which is what we're trying to solve for. So same idea that we did with the general formula when we're switching things around, right? That gave us an idea of the flow that we need to go through to solve these problems, right? And so we take 16,534.67 divided by 15,000 is 1 plus 0.0745 t. So divided by 15,000, I get 1.102311333 is 1 plus 0.0745 t. I can subtract 1 from both sides. I'll show all my work. You could probably skip this step because 1.1 minus 1 is just 0.1. So 1.102311333 minus 1 is 0.0745 t. So minus 1. I get 0.102311333 is 0.0745 t. So t is 0.102311333 divided by 0.0745. If you're ever falling asleep or having a hard time falling asleep, rather, you can just rewatch the video of me doing these calculations. 0.102311333. Yikes. I know. But I have to read them out, otherwise you'd have to be reading from the board this whole time. And then divide that by 0.0745. So T is 1.37330648 years. Remember, T is always in years, right? That's not very helpful for the days between dates function. So what we're going to do is we're going to say, okay, well, if I multiply 1.38, or 0.37330648. I can't help it. Can't stop. If we multiply that by 365, we get that in days. Right? So to find t equals 1.37330648 years in days, we multiply by 365. So t is 1.37330648 times 365. That's not actually true. That's not t, that's days between dates. But probably just me being picky. Right. Nice. March 22nd. Oh. I'm like, I guess we'll see. So take that whole number and multiply by 365. Oh, I know where you went wrong. It's coming up. And we get 501.256868 days. Here's the thing though, she can't pay it back at 0.256868 days. So she'd either pay it back at 501 days, but that wouldn't quite cover it all, right? So she'd have to pay it back after 502 days. So that's what we do. And I think that's what happened. Still. We'll see.
No, just from that number.
Yeah, so if you do 502. So now, we can't make a payment after 0.25686 of a day. So she needs to repay the loan after 502 days, right? So that's going to be important that you make sure when you're solving for time, there's that added little bit where you have to round your number of days to up, always up, right? To make sure that you're covered. So I'll make a little note here. Always round up for the number of days. So what we've got is we know date 1, or I'll bump it down a little bit to make room. Date 1, it takes date 2, and it takes the dates between dates. And I'll just put a little reminder that it needs it in the format month, month, day, day, year, year. Or month, month, dot, day, day, year, year. So date 1, we know, is November 5th, 2001. Oh. So November is 11.0501. We can make a note to ourselves kind of anywhere. 11.0501. And we also know the days between dates has to be 502, right? So this is one of those scenarios where we're solving for a date and not the days between dates. And so to show that that's what I'm solving for, date 2, I put a little star there, right? And that's how you're going to show your work to me. So you don't just have 502 to appearing somewhere, right? And then the second date appearing from somewhere. You have to show me how you got there. So again, we can go in our dates function, and I'm going to do 11.0501, enter. Make sure you hit enter. Scroll past date 2 because we're going to go back and compute it. Days between dates, 502, enter. And now I can go back up to date 2 and hit compute. And it was Saturday, March 22nd, 2003. Took her a while to pay back that loan. You don't have to have the Saturday, but I think it makes for a funny narrative. It was a beautiful Saturday morning, March 22nd, 2003. It's my dad's birthday, March 22nd. All right. Any questions about that one? So definitely more involved when we have to find T, right? Because there's usually that extra step where, okay, we're able to find the number of days, and then we use the days between dates. That can happen, right? But yeah, so we have to keep in mind that we can't just have a fraction of a day, for example, right? Then you have to round, and it's that added little step. No questions? All right. So moving on to the next section then, 4.6, equivalent payments. We've already seen equivalent payments just briefly when we looked at that trip to Vegas, right? The $3,900 and the $39.95. What rate makes them equivalent, right? And so, so we'll talk more about different ways that we can handle equivalent payments. First, we'll define it. Equivalent payments is two payments that enable you to end up at the same dollar amount at a later date. So it's two payments that enable you to end up at the same dollar amount at a later date. There's two other terms that we should define just because they will come up mostly in questions, but also when we're working through some of these problems, I'll throw them around. The first one is the payment stream. So a payment stream is a series of two or more payments required by a single transaction or contract, right? So I'll write this out and we'll talk a little bit about it. Two or more payments required by a single transaction or contract. So things like when you buy a car, if you're financing it, right, then you sign a contract that says that you're going to make a payment every month or bi-weekly or whatever, right? You're going to be making regular payments for some amount of time. That would be considered a payment stream. And we're going to talk more about those types of payment streams later on, because that's actually an annuity, where we have these regular payments coming out. For now, it's just going to be, I borrowed some money from you and I'll pay you back some of it in a month, and then I'll pay you back the rest in 3 months from now, right? That kind of payment stream. They're all payment streams, but we're going to be talking about just a couple of payments, maybe up to 5 payments or something like that. The other term that we should be comfortable with is the focal date. The focal date is just a date of importance to our calculations. It's the date that we're going to draw all our money to, right? And so when we were saying, oh, well, we could calculate the principal amount or the future value, the focal date would say, go to this point, right? And we'll see more about that. But the focal date is the date of importance to our calculations. All our money will be pulled. I say pulled, right, in the sense that the arrow is pulling it to that point. So all our money will be pulled to the focal point. Okay. Let's do an example. We'll start off kind of nice and slow, and then we'll build up. So here we go. Example 159. All right. So a particular investment pays $800 payments for 8 and 12 months from now. What is the most an investor should be willing to pay for this investment today if money earns a rate of return of 6%? Use today as the focal date, right? Because we want to know what's the value of $800 in 4, 8, and 12 months from now, right? What's that worth today? And so you wouldn't pay more than what it's all worth today for that investment. That just wouldn't make sense. So like I said, when we're drawing our timeline, right, we want to try to figure out, okay, how many dates do I have? Because that's how I'll start with all my ticks on my timeline, right? And so I know I want to have a tick at 4 months, at 8 months, and at 12 months, but also from today, right? And it also says to use the focal date as today. And so we've got 4 ticks that we have to put on our timeline, right? I don't bother, like here they are spaced out evenly, but even if they weren't, I don't space them out so it's proportional. I just space them out evenly. Even if it's, 5 months and then 5 years, I just put them evenly, you'll see. But here they're even, so it's a nice warm up. So we've got I don't know why I should make it a little bit longer. Don't know why I cut it short. There we go. Okay. So it's a timeline, right? So we start today, and then I'm going to make a tick at 4 months, at 8 months, and then the last tick is going to be at 12 months. 4 months, 8 months, and at 12 months. So there, I've got the first step of my timeline done, right? I've put the dates on, I've got my ticks up. And so this investment would pay you $800 at each of those 4, 8, and 12-month ticks, right? So what we do is we put 800 below each of these, right? Because that's what we would be getting. And then it even says to use today as the focal date. If today is the focal date, right, that means that we're going to pull all these payments to today. Right? And so what I do, because it gets a little bit messy, is we want to have arrows going from each of these back to today, right? And so what I do is I start from the focal date and I draw an arrow from the one that's closest, because otherwise if I start over here, usually I end up drawing my arrow here and then I'd have to overlap it and it just looks a little bit ugly. It doesn't matter, right? But just as, you know, here's brush, right? So you can just do it like I do it. So start at the focal date, the one closest to it, and then we'll draw our lines blooming out, and then there won't be any weird overlap. Okay. Sorry about the sun there, guys. Maybe I can at least pull this one down. It'll be really dark in here, but also still bright on the screen. Better? Yeah. It's so dark in here. All right. So what I'm going to do is I'm going to draw this arrow here. This arrow, and then finally this guy, and they each kind of get a line. Why not, right? We've got space. Okay. Each of these arrows are going to be some principal amount, right? And because I've got P, P, and P, I'm going to just put little subscripts on these just to indicate which one is which. And so I've got P1, P2, and P3. You can call them P4, P8, P12 if you want, right? Something that helps you remember which one's which, but with the timeline, you can just look at it and say, oh, P1 is the one for 4 months from now, P2 is the one for 8 months, P3 is the one for 12 months, right? But whatever you want to do. And then if we add these all up, that's going to be the total value of this investment today. Right? So this is the total value of the investment today. If we add those all up. All right, so we have to put time on each of these arrows, right? They're all in months from today, right? And so here I've got T1 because I'm gonna have T2 and T3, right? So I just use little subscripts to denote which grouping it's from. T1 is 4 out of 12, right? 4 months as a year is 4 over 12. T2 is 8 over 12. And then T3 is 12 over 12, which is 1 year. If you just wanted to keep it as 12 over 12, just to keep it the same, that's fine. But, and then somewhere on this graph here, we'll put that the rate was what? 6%, 0.06. Right. So this is our complete timeline, right? This is showing everything that you need to solve this problem, right? we have to find P1, P2, and P3, add them all up, and then that's the answer. That's the total value of this investment today. So you'll find that I flip-flop a little bit depending on what I have to do, right? I'm looking at this and saying, man, I have to solve for P 3 times. You know what I'm going to do? I'm going to solve for P in the general equation and then just use that later on, right? So here's what I mean by that. The future value is P times 1 plus R times T. You totally could go in and use that every time and solve for P every time. It's not that much work. But if I do this and say, well, then P must be the future value over 1 plus RT, now I can just use that formula. The rule is, if the formula that you want to use is not on the formula sheet, you need to show me how you got it, right? Then you can use it and reuse it if you want to, even throughout the entire test, right? Because we're talking test scenarios here. But as long as you've shown me at some point that that's how you found P, then you did it. So now I can say that P1 is, the future value of P1 is 800, right? Yeah. In this case, all the future values are 800, but it can very well be later on that the future values are different. So you really want to keep these things straight, right? And so we've got the future value over 1 plus RT is 800 over 1 plus R is going to be the same for all of these, 0.06. But the T, right, changes for each of them. That's the only thing that's changing for each of these, right? So we've got times 4 over 12. So I've got 4 over 12 times 0.06 plus 1, oops, 1.02. So I get, and I am skipping some steps showing them here, 1.02. Only because I'm feeling lazy, because I know I'm going to have to calculate 3 of these, right? So just make sure you end up with 1.02 in the denominator. And then so we can do 800 divided by 1.02, and we get $784.37255, just to check your answers, which in money is 784.31. What we're saying here is $784 today is equivalent to $800 4 months from now. Okay. So that's the idea. That's the time value of money concept that we really need to get a handle on for the rest of this course, right? Because $784.31 today is going to be worth $800 4 months from now, assuming that the rate is 6%. Right? And simple interest. P2, same idea. We get 800 divided by 1 plus 0.06 times 8 over 12, which is 800 divided by, so 8 over 12 times 0.06 plus 1. I get 800 divided by 1.04. Is 769.2307692. So in money, 769.23. And then finally P3, right? So same idea, $769.23 today is the same or is equivalent to $800 8 months from today at 6%. So we've got P3, same idea, 800 divided by 1 plus 0.06 times 1. So 800 divided by 1.06 is 754.7169811, which in money is 754.72. So the total value of the investment today is, so the total is P1 plus P2 plus P3. Which we said was, I think I have them here, 784.31 plus 769.23 plus 754.72. Which is, I have 2,308.26 in my pre-baked answers here. What that's saying is that $2,308.26 today is equivalent to $800 4 months, then 8 months, and then 12 months from now, right? So those are the same, right? So if the bank said, hey, if you pay us $2,400 now, we'll pay you $800, $800, that's not very good, right? Maybe if they did something lower than this, then you would say, oh yeah, sure, that sounds good, right? Because you know that the value of that 800 today is 2308.26, right? So that way you're able to compare what's a good deal and what's a bad deal, right, for investments. Okay. All right. Just a quick note. I have, so what we're doing here, when we're backtracking, we're calculating the principal amount, is we're discounting. Okay. So discounting is the process of calculating a payment's present value or principal amount. Principal amount or present value later on. Okay. Because if you think about it, $800 was discounted to $784.31, and then $800 was discounted to $769.23, right? Because it's going to be worth less if you're moving it backwards, right? On the other hand, $784.31 grew to $800, right? And so then it's just earning interest and it's growing for the future value. Okay. Just want to see. Let's do one more example. I know I'm working you guys hard today. Example 161. So example 161, here we go. Okay. Calculate the fair market value, so essentially the equivalent payment of the scheduled payments 60 days from now. So what are these payments worth 60 days from now? If money can earn 8.5%, the payments are $1,000 today, $1,500 in 70 days from today, and then $2,000 in 210 days from today. Okay. So here we really have to keep our wits about us for the timeline, right? But if you start by figuring out how many dates you're dealing with, right, then you can start and you can draw your timeline, put your ticks on, and then you can kind of, I don't know, weed out information, right? So if we read this, then we've got a payment today, a payment in 70 days, and a payment in 210 days. But we want to know how much is this worth in 60 days from now, right? And so we've got 4 ticks again. So here we go. And like I said, I don't bother with the spacing because I like to have as much room as I possibly can. And it doesn't really matter. It's more for visualizing. So I'm going to make this first blip today, right? Because that's the first date on this timeline. The next blip I'm going to put at 60 days from today. And then I've got one at 70 days from today. And I've got one at 210 days from today. All right. So now, next step, we put the dollar amounts underneath each of these blips, if they have a dollar amount, right? And so we make a payment of $1,000 today, $1,500 at 70 days, and $2,000 in 210 days. If we want to find the value of all these payments 60 days from today, that 60 days from today is the focal date, right? So the date that we want to know the value at, this is our focal date, right? So calculate the fair market value of the scheduled payment 60 days from now. So this is the focal date. So the focal date, right? Remember, that's where all our payments get drawn to, right? And so we want to know how much are all these payments worth at 60 days. That means that I have to pull this one forward, right, to be a future value. But I have to pull these two back to be a principal amount, right, or a present value. And then if I add these up, that's the total amount that's going to be worth 60 days from today, right? So we draw that out. So we've got this $1,000, and it doesn't matter which arrow you draw first, but as long as they're all going to 60 days, right? So this becomes a future value, right, because it's going forward. These other two are going backwards, so they're being drawn back to a principal amount. And I don't like my amounts to overlap, so I just give them each a row. So I've got P, and then I've got another P here. So I do P1 and P2. You could even do future value 1, P2, and P3, right? just to indicate which order you're going to calculate these things, but I don't know. I didn't do that for this one. And then, oh shoot, you know what I'm going to do? I'm going to bump this up only because I've got this page break and I only need one more line. So I'm going to squeeze one more line out. Oh, there. Move this. Squeeze it in. Nothing changed, just so it doesn't look weird when it saves as a PDF. So this is the fair market value, right? The total, if you add those up, is the fair market value after 60 days, right? Which is what we're trying to find. All right. Easy part is putting R. I'll just put R over here in the corner, 0.085. We don't want to forget putting the time on each of these arrows, right? They're all in days, so we have to divide them all by 365. And so we've got T for this one. T is 60 over 365. Here's where I should have used that subscript on the future value, right? So I can keep track of my T, 1, 2, 3. That's okay, it'll just be plain T. T1 is 70, what was my mistake? Trying to go too fast. There's only 10 days between 60 days and 70 days, right? So T1 has to be 10 over 365. Phew. And then T2 is 210 days from today, but not from 60 days. And so that puts us at 210 minus 60 is 150 days over 365. And what we'll do is we'll finish working on this one next day, but I think it'd be a really good exercise for you to go through because this is the complete timeline, right? So now if you just go through and calculate these, then we can just kind of zip through them next day. Otherwise, see you on Tuesday. Have a good weekend. Oh, unless there are questions, but I didn't get the feeling there were. Oh. Oops. Hey, Caroline.